Hello, in this video we're going to go over problem 2 from 2023 University of Maryland High School Math Competition Part 2. Let n be an integer greater than or equal to 2. There are n houses in a town. All distances between pairs of houses are different. Every house sends a visitor to the house closest to it. Find all possible values of n for which we can design a town with n houses where every house is visited. Okay, so I'm going to start from n equals 2 and then see if we can find a pattern for all the n's that this is possible, and then we will prove it. So for n equals 2, we have two houses. Whatever distance that they have, house 1 sends a visitor to house 2 and house 2 sends a visitor to house 1. So n equals 2 actually does work. Let's look at n equals 3. We have three houses with different distances between them. So let's say this is 1, this is 2, this is 3. So this is A, B, and C. After the visitors are sent, A sends the visitor to B, B sends a visitor to A because that's the shortest distance, and then C sends a visitor to B, which means that does not work. So n equals 3 does not work. Now for n equals 4, I can kind of basically apply the same thing that I had for n equals 2 and do this setting. So I have 1, 2, 3, 4. Make sure that these 6 instances are all distinct and send 1 to 2, 2 to 1, and then send 3 to 4, 4 to 3. So n equals 4 in fact does work. Now let's look at n equals 5. So if we look at n equals 5, we can kind of consider the shortest distance. So let's say A and B are the closest two houses. These two must swap visitors, and then for the rest of it, we'll have to basically use induction. So the claim is this. The claim is that this works if and only if n is even. So first of all, if n is even, here's how we can produce a town. So we take the houses and we set them in n over 2 pairs. So we have n over 2 pairs, and we are going to make sure that these two are closest to each other, and these two are closest to each other, and these two are closest to each other, and so on. And we're going to make sure that all the houses have distinct distances. Now we're going to send 1 to 2 and 2 to 1, so that swaps the visitors here. 3 and 4 are going to be swapped. 5 and 6 are also going to be swapped, etc. So that means for n even, we can create a setting like this. Now, what if n is odd? So let's assume n is odd, and such a setting is possible. So if that's the case, then we're going to look at two houses that are closest in distance. So let's say houses A and B have the shortest distance. When they send visitors, A must send a visitor to B and B must send a visitor to A. So what does that mean? It means the remaining n minus 2 houses must also satisfy the property that we are given. So n minus 2 must also satisfy the given property. But that is a contradiction. So the way we can create a contradiction is we're going to assume that n is an odd number and n is smallest. We know that n equals 3 doesn't work. We just talked about why n equals 3 does not work. So if we take the smallest possible, we get a contradiction because we just showed that n minus 2 must also work, which means n cannot be the smallest possible. For n odd, we showed that it is not possible. So then the answer is n is even.